Hello again. Here's another quick presentation for my listeners. Now, I've Googled, in quotes, pulsars as giant electromagnets. Google this to see if you can find something yourself. Pulsars are electromagnets. Meaning, you have your current carrying conductor conducting electricity, forming a magnetic field, like a solenoid type thing. And if you put an iron core in there, it'll increase the strength of the magnetic field through the loops of wire. That's what I think pulsars are. They're giant electromagnets. That being said, I'll save that for a little bit later in this talk. You have pulsars, and these are actually observed, believe it or not, these are not theoretical, ejecting beams of matter outwards from their interior. Huge beams of matter with many, many million electron volts of energy flowing through the beam, slamming into material, causing nuclear transformations. I know you guys remember a previous talk I made concerning stars not being the source for nuclear transformations because they simply were not energetic enough, given their internal temperatures could be over 20 million Kelvin. Theoretically, I don't think it's that hot in the center. But even then, the max temperature for the interiors of stars would be K electron volts. Kilo electron volts, 3.5 from the thermal energy. So clearly, stars, while fascinating, do not hold the torch when it comes to nuclear transformations. Now, if you have something that can eject a beam of energy at 70% the speed of light, you're going to have an incredible amount of nuclear transformations occurring in the actual beam as the beam slams into more material. As well, we should also remember our Newton character. For every force, there is equal and opposite reaction. Meaning after a supposed supernova, I'm not too sure how those things occur, explodes, I don't think is an exploding star. It might be something similar, but I think there's something more to the picture than what meets the eye. After that thing explodes, or forms, I should say, a pulsar in its center, this pulsar ejects the beam. Now, if you have a beam traveling at 70% the speed of light in one direction, essentially that's like a rocket. More powerful than a rocket. You have that material coming out 70% the speed of light. That thing's boogieing, okay? That means this object will be going this way. It will have a direction of travel in this direction. So you have your force going that way, and the actual object will be wanting to go this way. Equal and opposite reaction. Meaning, pulsars, they eject themselves out of galaxies and are really, really fast because they have a big beam of energy coming out of their butts, basically. These are what I would like to say galaxy seeds. When these objects exit large spiral galaxies, they continuously eject more and more matter, and eventually I think what happens, I haven't got there yet, but the beam not only goes that direction, but it slows down, and then it starts going out this direction as well. And it just radiates and radiates and radiates and makes all the material required for stars to be formed out of. Remember when I talked about Hercules A? It had these huge lobes of ionized matter coming out of it. Hercules A. That's what I think is the eventual evolutionary path of a pulsar, meaning essentially a pulsar is a young quasar. It's a brand new baby galaxy or a galaxy seed. And it's traveling so fast, it has this kick mechanism because the beam is pushing out the back end of it. For instance, B1508 plus 55, I don't know why they named it that, I have to look that up, I feel like an idiot, is traveling at 1,100 kilometers a second. Now, I don't know about you, but that is one hell of a fast traveling object. And all this being said in the beginning of the talk, the pulsars, the beams they eject, resemble particle accelerators. They're similar to particle accelerators. That they use strong magnetic fields, electromagnetic fields. Yeah, we know that because pulsars have huge, powerful electromagnetic fields. They're essentially giant electromagnets to propel charged particles to high speeds, yes, high speeds, 70% the speed of light, and to contain them in well-defined beams. We have that too. The beam is coming out of the pulsar as it is propelling itself. So basically what we have here are incredibly powerful objects which contain enough energy for nuclear transformations to occur. Unfortunately, a lot of scientists, they think that nuclear transformations occur in stars. And, well, the whole supernova nuclear transformations where iron, elements heavier than iron are formed, I'm not too sure about that either. And we all know that, Big Bang is absolutely false because it violates basic rationality and logic. You can't form something out of nothing. It doesn't work like that. So what we have here is, I'll go ahead and erase all this real quick. What we have here is a simplification of what's going on, at least what I think is going on. The establishment has, supernovas creating matter, and it has Big Bang creating matter. And it has stars creating matter. I don't think it's that complicated. I think what actually happens is you have some type of event happening from pre-existing matter. Okay, that's the formation of a pulsar. And then that pre-existing matter ejects stuff outside with very high velocities. This is where nuclear transformations are occurring. This is where the nuclear events are occurring along these jets. And this matter is probably really light, maybe comprised of superconducting helium or superconducting hydrogen, and it's acting really strangely. But then you say, where does this helium and hydrogen come from? Well, helium and hydrogen are the byproducts of radioactive decay. You have alpha particles, which are the nucleus of a helium atom. Okay? And then you have beta particles, which are the naked protons of a hydrogen atom. So basically, since the universe is eternal, where do you get all your hydrogen and helium? Well, it's not synthesized. These elements were never synthesized. They've always just been the byproducts of radioactive decay. And because there's so much of it, well, we can reason that the majority of the helium and hydrogen is actually outside of galaxies. It's just decaying and staying there. And say you have like a galaxy, traveling in the supposed direction, it just goes through large places where there's supposedly no matter according to the physicists, but really there's a lot of hydrogen and helium in the way. And it just recharges itself from all that radioactively decayed stuff that's just floating there. But that's really hypothetical, and I just want to get people's minds to think differently concerning this. It's not something that we should accept right off the bat, but I'm just disappointed as to why scientists have never considered that maybe transformations occur somewhere else. They've never considered it. They've always been pushed into stars and nuclear reactors, and that's the facts. And anybody has to say anything against it, you're wrong, and you're an idiot or whatnot. And I just think it's a very unhealthy way of looking at scientific progress, especially when over history, over very many thousands of years, humanity has always been known to make great mistakes with their assumptions. And it's basically the way things go. You make great mistakes, and then you correct them, and you make more mistakes, and you correct those. And over time, the process of scientific discovery and the evolution of our understanding is, in the words of Jeffrey Burbidge, hammered out. The way is hammered forward. But hopefully people can use some of these ideas to their benefit. If you have any questions or comments, please leave them below.